Alrighty folks, in this video I want to go over polynomial inequalities. Okay, so, and also rational inequalities. So what do I mean by a polynomial inequality? So at the end of the day, I need you guys to realize this. Consider these two separate problems, okay? I already have one put there, but let's consider this. What if I asked you to solve the following? Solve, let's see, let's say it's negative x plus 2 times x minus 4 equal to 0, okay? If I ask you to solve an equation like that, then we're going to have a certain number of solutions, right? In this case, we're going to have two solutions, right? We set both our factors equal to 0, and we get an answer of x equals a negative 2, x equals 4. And we know from previous lessons, those are the zeros, right? Okay. So whenever you're asked to solve a function setting it equal to 0, you're going to get a finite, what we call a finite number of solutions. But when it comes to inequalities, you're not worried about just, the answer is not going to be just one or two solutions. It's going to be a set of solutions, okay? So consider, and this is what we have going on to the left here, consider this question. The question here now becomes, what if I asked you, what if I told you, hey, f of x is the same function, negative x plus 2 times x minus 4. What if I asked you to give me the values of x such that f of x is, let's say, greater than or equal to 0? So now this is a slightly different question, right? So now the answer is not going to be just negative 2 and 4. It's going to be a set of solutions. Well, look over here to the left. And what I have over here to the left is a graph for you. And on this graph, it's the graph of the parabola, right? And so you have, from what we saw before in the previous problem, is you have your two x-intercepts, your zeros, right? And you have a 0 at negative 2, which is indicated here, I'm trying to fill in. And you have an x-intercept at a positive 4. Okay, it's a negative leading coefficient, so that's why the parabola is upside down, yada yada, and we go down forever. Okay, so what is the answer to this question? What values of x are there such that f of x is greater than or equal to 0? What you're asking for in this question is you're saying what values of x is my parabola above the x-axis? This means positive. Or 0, okay, since it's a greater than or equal to 0, right? Okay, so I'm going to try to attempt to shade in the part of the parabola that is above the x-axis. You guys see that? So that shaded region, that is the answer. All of those x values that encompass that shaded part of the parabola is our answer. So what's the answer? It's going to be our parabola is above the x-axis for the following x values. We're going to include negative 2, remember we're talking about x values, negative 2 up to when we get to 5. And we're going to include those. Why are we including both of those? It's because it's a greater than or equal to 0. What if instead the question said, hey, for what values of x is f of x strictly less than 0? Now we're talking about the values of x such that the parabola is below the x-axis. You see that? And so what would that answer be? In this case, the answer would be, okay, remember we're talking about x values. This left branch of the graph here, remember this goes down and left forever. So that means that the x value is going to be from negative infinity, because it's going to the left forever, up until we get close to an x value of negative 2, but we're not going to include the negative 2 this time. Why is that? Because it's strictly less than. But that's not the only part of the parabola that's below the x-axis. We're also below the x-axis for x values from 5, don't include the 5, to positive infinity. Why positive infinity? Because now this part of the graph is going down and it's going to the right forever. Keyword is right, because these answer choices are in terms of the x values. Okay? So that's kind of the heart of what we're going to be doing. Instead of looking at graphs, I'm going to show you another way of doing that, but that's what it is. You're just analyzing, do I need to be above or below a certain part of my graph? Okay, so for example here, suppose f of x is x to the fourth minus 9x squared. And the question says find all values of x such that f of x is strictly greater than 0. Strictly greater than 0. Well, instead of graphing this, this is what you should do. The first step is find the zeros, find the x-intercepts for this function. So let's do exactly that. We're going to take x to the fourth minus 9x squared. We're going to set that equal to 0. We're going to solve this via factoring. So the first thing you look for is the greatest common factor. In this case is an x squared we can factor out. That leaves us with x squared minus 9. And we can further factor that x squared minus 9, treating it as a difference of squares. So x squared times x minus 3 times x plus 3. So that equals 0. And that indicates that we're going to get 3 different solutions. Why is that? Because we're going to set up 3 different equations. Make sure we're clear here. Ooh, that's a nice color. X squared equals 0. X minus 3 equals 0. X plus 3 equals 0. Okay. Taking square roots of both sides here. X is equal to 0. X equals positive 3. X equals negative 3. Okay. So those are the zeros of this function. So what do we do next? So without even graphing it, this is what you do. We call this a sign test. This is what you do. Okay. I'm going to draw a number line. This number line represents my x-axis going from negative infinity to positive infinity. What I'm going to do is I'm going to now put these the zeros on my number line, and just the zeros. And make sure you go in the correct order as you go from left to right. So as we go from left to right, we're going to have a negative 3, then 0, then positive 3. Okay. And remember, the answer to this question is going to be an interval. It's not going to be just one solution. So what we've done is we've broken up our number line, all real numbers, into 1, 2, 3, 4 different regions. And what we're going to do is we're going to grab representatives from each of the regions, not the zeros, but a representative in the region. And then we're going to plug it into the original function, and we're going to determine if we get a positive or negative value back. Okay? So for instance, in this leftmost region here, I need a number that is smaller than a negative 3. Well, negative 4 should do the trick. So what you do is you take negative 4 and you plug it into your function. Okay? So here we go. In fact, let me pull up my calculator. Yeah, give me 1 second. How do I do that? Let's turn this off. Okay, let's pull up our calculator. What's our function? X to the fourth minus 9x squared. X to the fourth minus 9x squared. Okay, let's go to our table. And we plugged in a negative 4. And we get a value of a positive 112. So all I really care about is the sign of that y value. Is it positive or negative? In our case, it is positive. So what I'm going to do is I'm going to go back to my graph, and for this region here, I'm going to put a plus. So what that indicates is for any x value in that particular region, we're going to get something positive. So that means the function here is lying above the x-axis. And we're just going to repeat that for all of our regions here. Okay, think of a number between negative 3 and 0. I can do a negative 1. I could have done a negative 2. I could have done a negative 2.99 if I wanted to. All right, so we're going to go back to our calculator, plug in a negative 1, and we get a negative 8. So that means we are negative in between that region. Okay, let's keep it going. Let's do f of a positive 1. Okay, calculator, type in 1. We get a negative value again. Oh, negative value again. Okay, and then from 3 to positive infinity, we're going to plug in, let's plug in a positive 4. Okay, 4 gives us a positive value, positive 112. All right? All right, so once again, only put your zeros on the number line, your x-intercepts, okay? All right, so what does that mean? So the original question says, for what values, let's come over here, for what values is f of x greater than or 0? So that means, what do you think? Are we looking for something positive, a plus, or a minus? Well, greater than 0 means we're looking for positive, so our answer is going to be everywhere that we have a plus, okay? And because it's a strictly greater than, we're going to use parentheses when we get close to these zeros. Okay? So our final answer is going to be, well, this function is positive from negative infinity up to negative 3, not including it, union with, where else are we positive? We're positive from 3 to positive infinity. That's our answer. Okay? So those are the steps, folks. You find the zeros, put them on a number line, and then test all the regions, and then do your pluses and minuses, and then determine, okay, which sign do I want? Do I want a plus or do I want a minus? See if we can try a few more here. Another example. Go through this one quickly. Suppose f of x is equal to x squared minus 4x minus 12. And let's say we want to know where this function is less than or equal to 0. So it can either be 0 or negative. We call that non-positive. All right, so we know the drill. Let's first of all find our zeros. Okay, this involves some factoring. So let me see. 6 times 2 gives us 12. Let's get the right signs here. So x minus 6 times x plus 2. Which indicate our zeros are x equals a positive 6, x equals a negative 2. All right, let's get it. Let's make a number line. Okay, be careful. Remember the left side is negative infinity, positive infinity, and then we're going to put a negative 2 first as we come from the left, and positive 6. All right, let's go. Let's plug in a value. So what can we plug in that's less than a negative 2? We can do a negative 3. Into a negative 3. Okay. And let me show you a little trick here, a little shortcut. If you don't want to go to your calculator and try to figure out what it is, remember, all we need is the sign. This is what you can do, actually. So f of negative 3, look at your factor form, right? Remember, it's x minus 6 times x plus 2. Let me put in a negative 3 into that factored form. So I have a negative 3 minus 6, and that's going to multiply a negative 3 plus 2. Okay, well, negative 3 minus 6, that's a negative number. So I'm going to have some negative times a negative 3 plus 2 is another negative. Well, a negative times a negative is a what? It's positive. So that means that we are positive for that region there. Okay, if you don't like it that way, hey, look, go back here, y equals, put in your x squared minus 4x minus 12. Go to your table. And what do we plug in? We plugged in a negative, what do we plug in? A negative 3. And boom, you can see it's positive. So remember, it's called a sign test. All we care about is the sign. We don't care about the numerical value. I'm going to just do it the shortcut way from here on out. All right, in between negative 2 and 6, ooh, what about 0? It's a nice one. 0 means, right, plug into my factored form. That's 0 minus 6 times 0 plus 2. 0 minus 6 is a negative. 0 plus 2 is a positive. A negative times a positive is something negative. Okay, and then one more region. We have f of, let me do 7 here. And let's see here, go to the factored form. It's going to be 7 minus 6 times a 7 plus 2. Both of those look to be positive. A positive times a positive means we're going to end up with a positive. Okay, so this time, what are we looking for? Are we looking for pluses or minuses? This time we are looking for minuses because we want to be negative. We want to be less than or equal to 0. Because we can equal 0, we also are going to include our endpoints. So the answer here will be including -2 up to 6, and we have to include both of those endpoints because it could be equal to 0. All right, one more example. Lastly, how do we find inequalities of rational functions? So this is a good one. So for example, suppose we have f of x equals x plus 3 over x plus 6. And suppose they want us to find where is f of x, let's say it's greater than or equal to 0. Okay? I'm going to come over here. Keep in mind here, always keep this in mind. That's why we talk so much about domains. Look at that original function. What's the domain? The domain will be all reals except for whatever creates a 0 in the denominator. In this case, if you take x plus 6 at equal to 0, you get a -6. So just keep that in mind. -6 cannot ever be part of our solution here. Okay? All right. So when it comes to finding the zeros of this function, you do the same process, right? You take our function, x plus 3 over x plus 6, and this is what I want to do here. We're going to set this greater than or equal to 0. Let's do that, okay? And here's the trick for the rational inequality. So there's different ways you can go about this, but I like this way the best, okay? I want to get rid of my denominator. But I have to be careful because remember, what happens if we multiply or divide by a negative? We have to switch our inequality. So to avoid us worrying about switching, we need to make sure we multiply both sides of our equation by a positive value. So what we need to do here is multiply both sides of the equation by not just by x plus 6, but by x plus 6 squared. So the key with these inequalities, with rational functions, with the fractions here, multiply both sides by the square of that denominator. Because now we don't have to worry about switching the sign, the inequality. Okay? On the left side, the denominator of x plus 6 is going to cancel out one of my x plus 6 factors there. So on the left side, I'm left with x plus 6 times an x plus 3 has to be greater than or equal to 0. Right? Because 0 times x plus 6 squared is still 0. All right. Stop right there. Right now, as I look at this, x plus 6 times x plus 3 has to be greater or equal to 0. I can automatically right here say, oh, I know what my zeros are. Right? Because I have a function and I can set it equal to 0. So the zeros here, the x-intercepts, as you will, are what? X equals a -6 and x equals a +3. So those are the values we're going to put on our number line. Okay, -infinity, +infinity, -6, and -3 as well. Oh, I forgot my negative. -3. Okay? All right, here we go. You guys know the drill. I want to know f of, let's say, a -7. Okay? Think about it. It's going to be, I'm going to do the factoring trick, right? This means it's going to be a -7 plus 6 times a -7 plus 3. Let's see, we got a negative times another negative. This is going to be positive in this region here. Okay. What else do we have? Let's say we wanted to do f prime of a -4. That's somewhere in this region here. Let's plug that into our factored version here. That's a -4 plus 6 times a -4 plus 3. Looks like we're going to have a positive times a negative, so that means we're going to end up with an overall product of being negative. Then lastly, we can have f prime of 0. 0 is bigger than a -3. And what does that lead us to? Once again, I'm plugging it in. If it's not clear, I'm plugging my x value into here, and I'm trying to see what the sign is going to be. That's going to be 0 plus 6, which is positive, times a 0 plus 3, which is also positive. A positive times a positive is a positive. Okay, So what sign are we looking for? What sign are we looking for? We're looking for the plus sign. But keep in mind, -6 cannot be part of our answer. So what's the final answer here? We have a plus sign over here on this left side here. So we're going to go from -infinity up to -6, but we can't include the -6, unfortunately. Oh, sorry. And we definitely can't include the -infinity because we can't ever reach that. But the reason why the -6 is in parentheses is because we cannot include it. It's not part of our domain. Union with, where else are we positive? We're positive from -3 up to +infinity. And this time -3 gets a bracket because it equals 0, right? We want greater than or equal to 0. We want positive. And -3 is part of our domain. So I hope that helps you out. I didn't see anything that complicated on the homework, but yeah, if you have something like that, hopefully you know how to handle it. All right, see you guys in the next video.